Hey folks, welcome back to More Than a Refresh, the T3D sessions. I have a very interesting guest here today, Glauber Costa. His company rewrote SQLite in Rust. And today we'll be talking more about that in the new year, but today we're going to be talking about AgentFS, which uses this rewrite. Why don't you go ahead and give us, a little bit of description of what AgentFS is?
Well, thank you. First, thank you for having me. So AgentFS is essentially a virtual file system that allows your agents to run. I mean, AI is a technology that a lot of people are reaching out for, and it will give you an isolated view of what the agent is the files that and assets that the agent executes and generates. It gives you the ability to snapshot that. It gives you the ability to move that from place to place. And have native observability with a richer semantics than a file system would have. One way to explain that in a very succinct way is that if you look at how companies are deploying AI agents in the compute side, they're all reaching out for sandboxes, right? If you use an LLM, you know they're a little bit insane. They are very powerful, but they can go places. And then the way you keep them constrained is that you put them on a sandbox. AgentFS is the data part of that sandbox, right? So whatever the agent generates, the files as it's executing, it gets all snapshotted, it gets control, and you can move from sandbox to sandbox as those agents are moving physical compute infrastructure.
Okay, so what you're talking about here is, and forgive me if I get this wrong, when I think of agents, I'm old school, right? So I think monitoring.
Yeah.
Which is totally not what we're talking about, really. But when you say it can move from sandbox to sandbox, what you're talking about is the ephemeral resources that can disappear, and it can continue to move forward, and a new sandbox has been fired up.
That's correct. So look, this one of the theses that I have is that infrastructure always, every time there's a new revolution, like we're seeing now with AI, what happens is that the old infrastructure becomes too heavy. And you have to find like what is the lightest version of what we need that can, but not lighter, right? So you've seen this with virtual machines, like virtual machines at some point where everybody was using virtual machines, but later it becomes like containers because containers are lighter, and you don't need all of the other things that the virtual machines are doing. And it is a similar story. So what we're seeing with agents is that when you have something like Claude Code or you have any other open coder or any other coding agent that you have now with LLMs, they need to be run in those sandboxed environments. And those sandbox environments, they need to come online in milliseconds. Like sometimes you're talking about 5 milliseconds, 10 milliseconds, something that, it's hard to do, even with the infrastructure that we have today. You're not going to boot a VM for that. Containers are in a sense fine. But when you look at the data part, like how you isolate those agents with the minimum level of isolation that they need, what we hear from a lot of agent builders and from a lot of people is just like, hey, the compute part is okay, but the data part is the problem. So that, we're a data company. As you mentioned, we own a rewrite of SQLite. We actually use that to implement AgentFS. But it will give you the ability, as you move that sandbox from one place to the other, it can get you the entire state of the agent move from one place to the other in a couple of milliseconds, because all the state of the agent is represented by a single SQLite file, and that's the connection between those two things, right? So what it is in a technical level, if you go one layer deeper, it is a virtual file system that is backed by a SQLite file. You're going to have a table with all the files, with the contents of the files, and then we can use that to expose it as a virtual file system.
So the SQLite, so I found it interesting. Something you fed me or you said was, we need to keep it at least as light. We can't go heavier than previous. And that makes sense. I mean, that's what a lot of people think is progress. Although I will say, as I've gotten older, I think it's okay to slow down just an inch.
It is.
Right? Yeah. But the persistence of SQLite, right? You don't have any, SQLite doesn't really run services per se. So it's not a Postgres where you've got an MVCC situation. You don't have forks of processes and master processes controlling other processes, those types of things. And that's, I'm guessing that's what's giving you your sub 10 millisecond response.
Absolutely. Yeah.
is that there is no real service associated. The service is all on top.
And it's more than that, because if you look at the existing compute infrastructure, right? Because what Turso is a rewrite of SQLite that we focus a lot on agent use cases in general. And the underlying thesis there is that in the age of AI, it sounds a little bit cliche, but you know, it doesn't make it less true. We'll need
Marketing
exactly
people are very good at what they do.
Yeah, yeah, it will need something exactly like you just described. I mean, something that doesn't have a process, that is very lightweight, and the reason for that is that we believe you're going to see those structures times a million, times a billion, sometimes times a trillion, right? So if you have 1,000 agents. And they all need to have they all need to have their own isolated databases and their own individual databases. Now you're talking about managing 1 million databases potentially, right? You're talking about million in a single company, perhaps 1 billion databases. If you look at the whole economy, a couple of trillion. And SQLite is the only database that counts its installations in the trillions. So we have something that is very lightweight. That's the core. That's the core of what we do. But when you start thinking about, okay, so now what kinds of problems agents run into that a lightweight database can solve, keeping state is one of them. I mean, it's not the only one, and our company tackles all of those problems. But the problem that AgentFS specifically tackles is this: how do you keep state? And state is usually not something that goes on a database. State is something usually that goes on a file system, which is why we call AgentFS. But if you look at the compute and storage infrastructure that a cloud provider will give you, a persistent volume will become attached to your pod in a couple of seconds, because now you have networking.
Well, it's also more expensive.
Way more expensive, but I think this will matter someday. But we are in the part of the curve in which nobody cares too much about it, right? It's the beginning of the AI days. It's like most companies on the frontier are burning money, and they don't necessarily, what they want is like fast. So right. If we look 5 years in the future, absolutely. And so I'm not disagreeing with that. I just think today that's not what people are looking for. And we happen to solve that very well too. I mean, it's a way cheaper way to do it, but it's the speed of getting this online and moving this, because now you have the SQLite file that can be moved very easily between two containers, between two processes, between two sandboxes, and you don't have to even move the entire SQLite file. You can move, and this is something unique to Turso in comparison to SQLite. We can have a sparse file, and then we only move parts of the file that you're touching, which with something that we call partial sync. So the idea here is really like of AgentFS is to solve the state management layer of the agent, not the database part. Like I need a database for me to store my data. We do that too, but not through AgentFS.
All right, so we got about 2 minutes left, and there's 2 questions I have on that. One, actually 3. One is, Rust isn't exactly known as a lightweight language. Okay. Mm-hmm. And I'm not knocking Rust. It's just, that's a fact compared to say C. Okay. Also, SQLite is known to have certain concurrency issues. Mm-hmm. Okay. So actually, I guess it's 2. Those are the 2. Why Rust? Number one, knowing a specific limitation. Not that's a bad thing, it's just a known thing. And then 2, how do we deal with, concurrency / persistence of SQLite?
Yeah, so both great questions. I think the way in which Rust is not lightweight is not just the way it matters here, because what people criticize about Rust is that, hey, it might generate a 5 megabyte binary instead of a 2 megabyte binary, but that is not the limitation in this case, right? The limitation in this case is that you don't want a server process with a network call, and so we slim it down in a different direction. If our binary is 5 megabytes and it could have been 3 megabytes if we were writing in a different language, that's not the make or break it. What makes it lightweight, what gives it the characteristic that we're looking for, is the fact that it's a serverless process that runs without a server infrastructure, as you described, and can be spawned by the billions, right? So just it's just a different axis in which we consider that. And the the rest of your question, it's essentially like, why are we doing this with Turso, which is a rewrite of SQLite? Why we reach out to a rewrite of SQLite instead of using SQLite to solve those agent problems? And it's exactly because SQLite has those limitations. So Turso, for example, does not have the concurrent writer limitation that SQLite has. You can have concurrent writers with Turso, and this matters for AgentFS because if you're cloning a Git tree, for example, into the virtual file system, what you're going to end up with is a lot of writes that happen concurrently, potentially with many threads, and they're all fairly small, but they have to happen in parallel. So Turso fixes those issues that SQLite has, and we use this as a foundation. And it's lightweight enough. I mean, we could do better on the binary size. Maybe we could do better in some axes, but Rust gives us so many other advantages, and that's not the axis in which we need to make this lighter.
Okay, and as we close out, what open source license are you using?
MIT.
Oh, awesome.
Plain and simple.
Yeah, that's I love it. All right, folks, this has been another T3D session with Glauber Costa. It looks like they're doing some really interesting things with Rust in terms of SQLite rewrite and AgentFS. We will make sure and put the Git repositories in the description of this episode. Thank you very much.
Thank you. Thanks for having me.